Let's start with a high-level overview of what Snowflake is. Even if you are actively using Snowflake day by day, I still think that it's a good idea for you to revisit the basics with me so we can start with a solid foundation. For those who are completely new to Snowflake, this lecture should give you a good conceptual understanding of what Snowflake is and what makes it unique in the data storage and analysis space. So, what is Snowflake? At its core, Snowflake is a cloud-native data platform offered as a service. This means users can leverage Snowflake capabilities without worrying about managing physical hardware, installing software, or even maintaining infrastructure. It's fully hosted and managed in the cloud. The reason we call it a data platform rather than just a data warehouse is because it offers a broader set of features than traditional data warehouses. Snowflake supports multiple workloads beyond simple data warehousing, including data science, data engineering, and application development. It even handles semi-structured data like JSON or Avro, a capability traditionally reserved for data lakes. To understand what Snowflake is, we will break it down to three different pillars. One is cloud native, second is data platform, and third, offered as a service. Each component of this definition is fundamental to understand Snowflake and why it's become so popular. Let's explore what each term of these means. Starting with data platform. As Snowflake gained popularity, the marketing and documentation surrounding it describes Snowflake as a cloud data warehouse, positioning itself as a predominantly analytics solution. However, Snowflake have gradually moved away from this description, now preferring the Snowflake platform as AI data cloud. This was done to underscore that Snowflake has been enhanced with capabilities beyond what you would expect from a traditional data warehouse and represents a convergence of variety data technologies in one place. Although still firmly rooted in SQL, it now supports a range of languages and workloads, which this screen captures here hints. Now let's run through Snowflake Data Platform key workloads and features. Snowflake is equipped to handle six primary data workloads. The first one is data warehousing. Store structured data in databases, schema, and tables and query it using SQL. Number two, data lake capabilities. Processes semi-structured data without predefined schemas. Number three, data engineering. Simplify data ingestion and pipeline creation using features like copy into, Snowpipe, streams, and tasks. Number four, data science. Centralized storage and integration with tools like Amazon SageMaker and Data Robot aid in building and deploying ML models. Number five, secure data sharing. Share data securely with other Snowflake accounts or via the Snowflake Marketplace. Number six, data application development. Support for UDF, stored procedures, and integration with programming languages and services like AWS Lambda. So we can see Snowflake is trying to cover a lot of bases, and it's a little bit more than just a data warehouse. Let's look at another component of our definition, Snowflake as a cloud-native solution. All the features and workload we just went through was purpose-built for the cloud. The vast majority of the software Snowflake has designed has been created from scratch to run on the cloud. The query engine, the storage file format, the metadata store, the caching, the architecture generally was designed with cloud infrastructure in mind. It's not what is called a cloud wash solution, which is a port of an old technology migrated to the cloud. The actual hardware, the storage, the compute, the load balancer, or the infrastructure that makes up a single Snowflake account and runs the software Snowflake designed is provisioned into one of the three leading cloud providers. It was originally designed to run on AWS and expanded to include Azure in 2018 and then Google Cloud Platform in 2020. An account like the trial account was created exists in a single cloud provider's region. Because of this, Snowflake inherits the many benefits of the cloud: high availability, the ability to always have access to services and data, scalability, so we can very easily add compute or storage resources, elasticity, so we can dynamically scale out based on demand, durability, guarantees, so we know our data is replicated and it won't be lost, and many more. Okay, let's look at what software as a service means, our third and final component of Snowflake. Hosted services in the cloud can be provided in various delivery models. You could have virtual machines hosted remotely, which are accessed and managed by a user, like EC2 instances in AWS. Snowflake is slightly different from that. It's pure SaaS product or software as a service product. This means that as user, there is no management of our account infrastructure at all. It's all very limited management of software, with the only real thing to configure being Snowflake connectors like the SnowSQL command line tool. Snowflake do expose some settings to tune the behavior of the platform, but this is done indirectly by setting properties via SQL or the UI. In Snowflake, the user performs no manual upgrades or patches to the software. There are weekly online updates and patches which are completely transparent to the user and causes no visible downtime. As this many SaaS product, Snowflake offers a flexible pay-as-you-use subscription model. The flexibility of this model allows users to pay only for the resources that are needed and is therefore generally cheaper than large upfront capital expenditure cost required to set up your own hardware and software. But of course, as always, there is an exception to this. Accessing Snowflake is very easy. No need to set up any software. You interact with Snowflake account through the UI by authenticating with username and passkey. This can optionally be extended with connectors and drivers for programmatic access, which we mentioned earlier. Optimizations like partitioning of data are done automatically, so there is no longer a need to specify things like static partitioning keys or indexes. These data optimization activities are done automatically as part of the loading process. So I hope you now have a better understanding of what Snowflake is. In the next lecture, we will get into the nuts and bolts of Snowflake unique cloud native architecture. So I'll see you in my next video. Don't forget to hit like, leave a comment and subscribe so you never miss any new content.